Download this code from codegive.com, link in the description below. Handling errors efficiently in Go is crucial for building robust APIs. Go's error handling philosophy emphasizes clarity and simplicity, making it easy to manage errors without throwing exceptions. Below is a tutorial that covers the best practices for error handling in Go APIs, complete with code examples. Tutorial: Efficient error handling in Go APIs. 1. Understanding errors in Go. In Go, errors are treated as values. The standard library provides an error interface that you can use to represent an error. This interface has a single method. Go. Type error interface. Error, string. When a function can fail, it typically returns an error as the last return value. If the function completes successfully, the error will be nil, otherwise, it will contain information about what went wrong. 2. Basic error handling. Here's a simple example of handling errors in a Go function. Go. Package main. Import. fmt. os. Func read file, file name string, error. Data, error equals os.read file, file name. If error, equals nil. Return, error / return the error to the caller. Return string, data, nil. Func main. Content, error equals read file, example.txt. If error, equals nil. fmt.printf, error reading file, %v\n, error. Return. fmt.println, file content. In this example, if read file fails, it returns an error that is handled in the main function. 3. Custom error types. For more complex applications, you might want to create custom error types. This allows you to attach additional context or data to the errors. Go. Package main. Import. fmt. / custom error type. Type file error struct. File name string. Error. Func, file error, string. Return fmt.sprintf, error reading file %s, %v, file name, error. Func read file, file name string, error. Data, error equals os.read file, file name. If error, equals nil. Return, and file error file name, error, / return custom error. Return string, data, nil. Func main. Content, error equals read file, example.txt. If error, equals nil. fmt.println, error, / prints the custom error message. Return. fmt.println, file content. 4. Error wrapping. Starting from Go 1.13, you can wrap errors using the fmt.error function with the %w verb. This allows for error unwrapping later. Go. Package main. Import. Errors. fmt. os. Func read file, file name string, error. Data, error equals os.read file, file name. If error, equals nil. Return, fmt.error, read file, %w, error, / wrap the error. Return string, data, nil. Func main. Content, error equals read file, example.txt. If error, equals nil. If errors.is, error, os.error not exist. fmt.println, file does not exist. Else. fmt.printf, error reading file, %v\n, error. Return. fmt.println, file content, content. 5. Using defer, panic, and recover. In certain circumstances, you might want to use panic and recover for exceptional situations, though this is not common in API error handling. Use defer to recover from panics and handle errors gracefully. Go. Package main. Import. fmt. Func risky operation. Defer func. If r equals recover, r equals nil. fmt.println, recovered from panic, r. Panic, something went wrong, / simulating a panic. Func main. Risky operation. fmt.println, continuing after recovery. 6. Structuring API responses. When building APIs, it's important to structure your error responses consistently. You can create a standard error response format. Go. Package main. Import. Encoding /JSON. Net /HTTP. Type error response struct. Message string JSON message. Func error handler, whttp.response_writer, error, status code int. w.write_header, status code. Response equals error response message, error.error. JSON.new encoder, w.encode, response. Func handler, whttp.response_writer, r*http.request. / simulating an error. Error equals fmt.error. An example error occurred. Error handler, w, error, http.status_bad request. Func main. http.handle func, / handler. http.listen and serve, 8080, nil. Conclusion. Efficient error handling in Go APIs involves returning errors as values, using custom error types when needed, wrapping errors for context, and structuring API responses consistently. By following these practices, you can ensure that your APIs are robust and provide clear feedback on errors. Handling errors efficiently in Golang, is a critical aspect of building robust APIs. Go's error handling philosophy is explicit and encourages developers to handle errors immediately after they occur. In this tutorial, we'll cover the basics of error handling in Go, common patterns, and provide a code example that illustrates these concepts in an API context. Understanding error handling in Go. In Go, errors are treated as values. The idiomatic way to indicate an error is to return it as the last return value of a function. If the error is nil, it means that the function executed successfully, otherwise, the caller should handle the error appropriately. Basic error handling. Here's a simple function that demonstrates basic error handling. Go. Package main. Import. Errors. fmt. / a function that simulates an operation that can fail. Func divide, a, b float 64, error. If b equals 0. Return 0, errors.new, division by 0. Return a/b, nil. Func main. Result, error equals divide, 4, 0. If error, equals nil. fmt.println, error, error. Return. fmt.println, result, result. Common error handling patterns. 1. Checking errors immediately, always check for errors right after the function call. 2. Wrapping errors, use the fmt.arif or errors.wrap functions from the github.com/package/errors package to add context to errors. 3. Custom error types. Define custom error types to provide more context about the error. 4. Logging. Log errors for debugging and monitoring purposes. Creating a simple API with error handling. Let's create a simple HTTP API that demonstrates error handling practices. We will create a basic API that allows users to perform operations on a list of books. Step 1. Define the book model. Go. Package main. Import. Encoding/JSON. Net/HTTP. Sync. // book represents a book in the library. Type book struct. ID string JSON ID. Title string JSON title. Author string JSON author. // in-memory store for books. var books equals make, map string book. var musync.mutex. Step 2, create handlers with error handling. Go. // getBook retrieves a book by its ID. Func getBook, whttp.response_writer, r*http.request. ID equals r.url.query.get, ID. mu.lock. Book, exists equals books ID. mu.unlock. If, exists. http.error, w, book not found, http.status not found. Return. w.header.set, content type, application/JSON. JSON.newEncoder, w.encode, book. // add adds a new book. Func add book, whttp.response_writer, r*http.request. var book. Air equals JSON.newDecoder, r.body.decode, end book. If air equals nil. http.error, w, invalid request payload, http.status bad request. Return. mu.lock. Books book.id equals book. mu.unlock. w.write header, http.status created. JSON.newEncoder, w.encode, book. Step 3, set up the server. Go. Func main. http.handlefunc/book, getBook. http.handlefunc/books, addBook. http.listenandserve, 8080, nil. Running the API. 1. Save the code in a file named main.go. 2. Run the application using bash. Go run main.go. 3. Use a tool like curl or postman to test the API. Testing the API. Add a book. Bash. Curl x post h content type, application/JSON DID:1, title: Go programming, author: John Doe, http://localhost 8080/books. Get a book. Bash. Curl x get http://localhost 8080/book, ID equals 1. Attempt to get a non-existent book. Bash. Curl x get http://localhost 8080/book, ID equals 2. Conclusion. In this tutorial, we covered how to handle errors in Go, especially in the context of building APIs. By using idiomatic error handling practices such as checking for errors immediately, providing context, and defining custom error types, you can create more robust and maintainable Go applications. Remember to log errors appropriately and provide meaningful messages to the users of your API, while ensuring that sensitive information is not leaked in error responses.